Right, number 22. Rectangles ABCD and EFGH are similar. Okay, so similar shapes, not the same as congruent. Congruent would mean if I had two rectangles that were exact copies of each other. They are identical in every way. They can lay directly on top. You can lay one on top of the other and they're going to line up perfectly. Similar means they are proportional. So it's going to look like I either shrunk or blew up one of these rectangles. So one will be smaller than the other, but you could enlarge this small one to make this big one, and it would then line up perfectly on top of it. So that's what similar is. They are going to be proportional. They'll form ratios that are consistent all the way around. So this side corresponds to this side, then there would be a proportion there, and it would have the same proportion of this side to that side and all the way around. That's what we're talking about when we say similar. Okay, so I have A, B, C, D, and E, F, G, H. The order in which they are given is important. So that A corresponds to E, B to F, etc. Right, back to our little problem here. They're telling us the length of each side of EFGH is 6 times the length of the corresponding side of ABCD. Get rid of my little highlights here because the undo feature isn't working. Okay, so the length on EFGH, 6 times the length of ABCD, each side corresponding. Okay, so I'm going to call this side up here X, and I'm going to call this side Y. So the corresponding one down here, AB, corresponds to EF, and we're told this is 6 times as long, so this would be 6 times X. And AD corresponds to EH. AD I'm calling Y. So this side is going to be 6 times Y. Right, next part of our problem says the area of ABCD is 54 square units. What is the area in square units of EFGH? Okay, is there any way to know the length up here of AB and AD, what that X and Y is? Is there any way of knowing? No, there is not. There's no way. One side could be 54, the other could be 1, could be 9, could be 6. Could be, it's just 18 times 3. We just don't know. There's no way of knowing. But we do know that I would need to multiply length times width to get the 54, to get the area. So I know that X times Y is equal to 54. Well, what is the area of EFGH in terms of X and Y? Not in numbers yet. We know that EF is 6X and EH is 6Y. So I would need to multiply those together to get the area of this other triangle, 6X times 6Y. I can multiply the 6's together because this is the same as 6 times X times 6 times Y. So I can multiply 6 times 6, gives me 36, and then the X and the Y just come along for the ride. So the area of EFGH is 36 times X times Y. Okay, I'm going to erase this, give us a little more room. All right, so I know X times Y is 54, so I'm going to replace that X times Y with 54. So now my area of EFGH is 36 times 54. And when I multiply those together, I get D, 1,944. And that's my answer. And that's how we can figure out the area of EFGH without knowing the length of either side. Hey guys, just a quick heads up. I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.